Welcome students to another video lecture with Mr. Kinnett. So in this lesson, we are going to expand off what we've been learning in our previous chapter 10 concepts about measures of center and variability. And we're going to learn how to actually use or create a system called a box and whisker plot and continue to use those measures of center and variability to analyze our data. So remember, if you're confused when we mention range, IQR, and those mean, it's important you're going to go look back in 10.1 and 10.2 for help. So go ahead and pause here and copy down what you see. Okay, welcome back, students. So our essential question is, once again, how do we compare populations utilizing box and whisker plots information? And this is really still going to base us on using our measures of center and variability, but we're going to learn how to create this box and whisker plot. It's really just a visual that we can create to help us analyze a data set. So on the next screen, when I do show you the box and whisker plots formats, please make sure that you do draw them as you see them, especially the symmetric and the skewed, because it's important we see what symmetric looks like correctly and what skewed looks like correctly. So here's what I mean. We have our box and whisker plots, and each of these pieces of our box plot has an informational portion. So pause here and copy down what you see. Okay, welcome back. So again, this is a different way to visually show our data sets, but it's still using information and skills we applied or learned from 10.1, 10.2. So we're just recycling those skills and showing them a different way. So this whole thing is called a box plot, and it may also be called a box and whisker plot. And it's kind of because it has a box, and those two side things coming out of it could possibly look like whiskers. So it could be either called a box plot or a box and whisker plot. So the first thing is this dot right here on the very left stands for our minimum or lower extreme. This dot on our upper right is going to mean our maximum or upper extreme. And this is all normally going to be placed on some sort of number line with data on it, like 20 and 18 and 16 and 14 and all of these, where these lines are located, stands for information. So just off based on the number line I placed here right now, our minimum would be at the same level as this 10 right here. As you can see, if we were to come straight down and look at our number line, our minimum is at the number 10. Let me get rid of those though, because it's not helping us read. Okay, these lines on the edge of our rectangle stand for the lower quartile on the left, and this one on the right stands for the upper quartile. And again, these are the numbers they represent on this number line I generically drew below. So this plot will always have numbers that it connects with. On this line in the very middle of our box plot will always be our median. And in this current number line, it looks like it's at about 16. Our upper here, our maximum, kind of looks like it's at number 20. So that's how we make box plots. Sometimes we're going to be able to make one of these by finding the minimum, maximum, lower, upper, and median, and we just place them and draw them appropriately. Each one of these sections here stands for what percentage of our data? If you said 25%, you're right. So each of these sections represents 25% of our data. And this from lower to upper is, as we already know, called our IQR, interquartile range. So some important things about this box plot would be considered symmetric if the box plot looks kind of like this one, where it's really equal on both sides. A skewed box plot looks like it's kind of shifted to left, or it could be shifted to the right. So it's important we understand these words skewed and symmetric. Okay, so let's keep on moving on here. Draw a squiggly line below that last box plot for skewed, and let's build this data table. What this data table is focusing on is, again, trying to teach us which measures of center or variability we should use based on what our box plot looks like. So, for example, this one will be used when the data sets are both symmetric. This middle column is what we should use. If neither is symmetric, we'd use the median and the IQR. And if only one is symmetric, we'd still want to use the median and the IQR. So again, this is kind of like our concepts we learned in the beginning, and we were learning how and when to use them. So pause here and copy down what you see. Welcome back, students. So we're about to go over 2 examples, and if this video lecture gets too long, I'll try and complete example 2 in class. So we're about to have some writing to go on because these are kind of word problems, so stretch that hand out, get ready. I'm going to show both parts of these problems, which it's going to have a part A and a B, so please make sure to leave space when we start writing these problems down. So what I mean here is, for example A and example B, don't put these right next to each other. Make sure to leave ample space for us to do these problems. So go ahead and pause here, and again, copy down exactly what you see, because these lines that correlate with our box plots are really important on the number line, so draw carefully. Go ahead, pause here and copy down what you see. Welcome back. Okay, so right now we're analyzing MP3 players from Radio Shack and from Kmart. And it's really important we always read our directions, because what this box plot is showing is costs of MP3 players. So please don't ever skip reading what the problem is about, because then it will make these box plots a little more clear and understandable. So we have Radio Shack and we have Kmart. Radio Shack's our green and Kmart is our red box plot. So we're going to start trying to analyze what some of these box plots can tell us. So part A in this problem says, which store sells the cheapest MP3 player? Which part of our box plot should we look at to answer this question? So I'm going to put that question that I just asked right here. Which part of our box plot should we look at? I'm going to give you a few seconds to think that through. Yeah, if we're looking for the cheapest, are we going to be looking at the minimum, the lower, the median, the upper, or the maximum on our box plot? Which one are we going to be looking at here if we're looking for the cheapest MP3 player? Yeah, if you said minimum, you're right. So let's just look at our minimums for each of them. And again, you're going to notice I use subscript here. So I got minimum for Kmart, and then I'm going to have minimum for Radio Shack. So our minimum for Radio Shack looks like it's at the 55 on our graph based on the number system they used. And our minimum for Kmart kind of looks like it's at 50. So once we've looked at these 2 pieces of information, what would your answer be? Can you write a sentence for it? We'll check in class that you wrote the correct answer. Okay, so now we're on to part B. Which store has the largest interquartile range for their NPR players? Well, again, if you don't know what an IQR is, go back to your 10.1 and 10.2 note, because this is just some simple math we're going to have to do. So let's do the IQR of Kmart. And again, you're going to notice I have subscript because we have the same thing being listed twice. To find the IQR, it's the max minus the min. And for Kmart, that's an IQR of $10. That's how far the lower quartile is from the upper quartile. Our IQR for Radio Shack is going to equal also $10. So they both have an equal span for the middle 50% of their data. That's what the IQR always represents, that middle 50% of our data. So based on this, which store has the largest IQR? Go ahead and write an answer. Again, we're not lying to ourselves. Sometimes the numbers are equal, so write an answer here. Okay, we have one more part to this problem, part C. So let's get to part C. Oh, I'm jumping around on the video here. Okay. Oh, yep, part C here. Which store has more higher priced MP3 players? how are we going to know which store from Radio Shack or Kmart has more price for their players? I'm sorry, I'm jumping around here, but I'm trying to hide that other example. So I'm going to write that question down. Which part of the box plot do we analyze to find out the higher priced store? So go look at your box plot and think which one of those pieces of information, there's 5 pieces on any box plot, it has a minimum, a lower quartile, a median, an upper quartile, and a maximum. Which piece of that information helps us figure out which store has more higher priced MP3 players? If you said median, you're right. So I need you to go find the median for our Kmart information and also find the median for our Radio Shack. And after looking at our box plots, it does seem that the median for Radio Shack is 70 and the median for Kmart is 60. So let's go ahead and write that down. Well, now that we've looked at that, can you answer the question with words? Which store has more higher priced MP3 players? Go ahead and try. Awesome. So other conclusions about what we can make about the data, I'll try and answer more in our class. So then I'm going to get us set up for our last and final example. And again, it has a decent amount of words. So this is where we'll complete our video lecture and we'll finish example 2 in class. So please make sure if you're absent to check the PDF uploaded or remind Mr. Cadet to upload the PDF with this correct work on it. So this has 2 slides that you're going to need to copy down and we'll finish this in class. Thank you so much, students, for another learning opportunity with Mr. Canet, and I'll see you soon. Go ahead, copy that down. I'll see you in class.